Step number 3 of how to plot root locus. So as we discussed earlier that root locus always start from poles of PS or GS, whatever you want to call it, and ends at zeros. So the number of different root loci or the sections of root locus are going to be equal to the number of poles. So if your zeros are less than the number of poles, that means that some of the zeros are located at infinity, and that section of root locus is going to head towards infinity, as I explained it to you earlier. For example, in this one, this is going towards infinity. There's a zero we are assuming located at infinity. This section is going towards infinity, and this section is going towards infinity because there is only one finite zero over here, and from this pole roots are going towards that finite zero. So first thing is, how many zeros are located at infinity will be number of poles minus number of poles minus number of finite zeros. That many zeros will be located at infinity. Now when zeros are located at infinity, they will be located along some asymptote, and we have to find the angle at which those asymptotes are located. So how are we gonna find the angle, as well as we are going to find the what we call centroid, or the point along which those asymptotes will be leading. So to find the point, or what we call centroid, asymptote centroid, on the real axis, we use this formula. Centroid is equal to number of poles, sum of poles, all of the poles of PS, minus sum of all the zeros of PS divided by n minus m. Remember, n is the number of poles, and m is number of zeros. So the difference n minus m is basically the number of poles minus number of zeros. So this is the formula using which we will find the point on the real axis, on the negative real axis, where along which the asymptotes will be located, and along those asymptotes we will have zeros towards at infinity. How are we going to find the angle of those asymptotes? To find the angle of those asymptotes along the real axis, with respect to the real axis, we will use 2k plus 1 over n minus m times 180 degrees, where k is 0, 1, 2, so on and so forth. So if we look at the last example, where ps 1 plus kps, ps was 2 s plus 2 over s plus 4, 1 0, 2 poles, uppercase n is 1, hence the centroid is going to be negative 4, that is sum of all the poles. Sum of all the poles means we have 2 poles, negative 4 and 0, so the sum of those is negative 4, minus sum of all zeros, we have 1 0 at negative 2, so minus 2, divided by uppercase n, which is 1, which will give us negative 2. And then phi a, that is what will be the angle along which, with respect to the x-axis, along which those asymptotes will be located. So phi a is 2k plus 1 over n minus m times 180 degrees. For k is equal to 0, it is going to give you 180 degrees. Now if you have more than one asymptote, in this case it's going to be one asymptote, as you know, because your uppercase n is 1. But if uppercase n is not 1, if it is 2 or 3 or 4, then of course you will have multiple angles for different values of k that you will have to calculate. K is equal to 0, 1, 2, 3, so on and so forth. In this case, we have one centroid and we have one angle. So let's see. Do I have the plot? Let me see. Let me go back actually. Right here when I plotted that. Where did I plot it? Right here. This is where I plotted it. So here it is. Your centroid is right here. In this case, centroid doesn't really matter actually, because it is along the x-axis, but your centroid was what? -2, and your angle is 180 degrees. So centroid is -2, angle is 180 degrees, or in this case, simply when it is 180 degrees, simply that there is a 0 located at 180 degrees. As simple as that. I think we have, let me see, is there another example here? Example 3, okay, fourth order system. Alright, so this is the same as I used for the project. S plus 1, S plus 2, S plus 4 is square. S plus 1, S plus 2, S plus 4. Okay, good. So let's see how we can do the root locus up to this point, up to step number 3 for this one. First thing is to locate zeros and poles of PS. So we know 1, 0, -1, 4 poles, 0, -2, and 2 poles at -4. So I have -1, 0, and then 0, pole, -2, pole, and then 2 poles at -4. That's the first step. Second step is to identify the sections of real axis which will be part of the root locus. So we're gonna start here. We have 1 pole on our right, that means even, odd number, that means this whole is the section of root locus. Come here, we have 1, 0, 1 pole, even number, this is not the section. Come here, we have 2 poles, 1, 0, this is the section. And then come here, we have 2 poles, plus 1, 3, 4, and 5. So all this section is part of the root locus. That's step number 2, to identify the sections on the x-axis which will be part of the root locus. Number 3, how many zeros are located at infinity? We have 1 finite 0 and 4 poles. So 4 minus 1, 3. 3 zeros are located at infinity. That means we need to know what will be the asymptotes along which those zeros will be located. So we go ahead and we calculate the centroid first. Sum of all the poles, that is 2 -4s, 1 -2, -10, minus sum of all the zeros, there's only 1 0 at -1, so -1 over 3, -9 over 3, which is -3. That means our centroid is located at -3, and this is the box which shows the centroid. What will be the angles of asymptote? 2k plus 1 over n times 180, and since we have 3 asymptotes, or n is equal to 3, then k value is going to be 0, 1, and 2. 0, 1, and 2. So when k is equal to 0, it's going to be 1 over n times 180, n is 3, that means 60 degrees. When k is 1, we have 3 over 3 times 180, 180 degrees. And when k is 2, we have 5 over 3 times 180, which will be 300 degrees or -60 degrees. So these will be our asymptotes. At -3, I have one asymptote along 180 degrees, I have one asymptote along 60 degrees, and I have one asymptote along -60 or 300 degrees. So that's the third step, is to calculate the centroid and the angle of asymptotes along which the zeros will be located at infinity.